End up doing today is kind of continuing with the sort of mathy uh, lessons. We have sort of part 2 here. It's another mathy lesson, meaning there's some notation. Okay, actually, we're not even going to graph anything today, which some people like. You're going to find out that we're going to do a composition of trig functions. Sounds pretty mathy. A composition is not like an essay that you write in math class. A composition is when you take two functions and you sort of put them together. So let me show you what we mean by composition. Again, we're going to take two functions and we're going to put them together. I'd like to do kind of like a consider, which is my way of saying maybe there's something you know about this, and maybe, there's some new parts. There are. But let's see if there's something we can take from the old and maybe apply it here. I got some sharp colors to help with this. How's my color coordination? We've got this nice blue. It says this cosine of the inverse sine of root 3 over 2. And we got that nice lime green. So it's the cosine of the inverse sine. Now, if I said to you, hey, I want you to see if you can figure it out, and we're going to kind of cut to the chase a little bit here, but if you're like, yeah, I think I could type that in my calculator, like just type it on the home screen, you're right. I mean, you could probably type it right now and see what happens. I'm not stopping you. But I'd like you to understand the theory behind this, because there's going to be some problems that we can't type in the calculator. So if you're typing it in and you're getting an answer, let's find out how to get that answer by thinking about something that we should know. Now, the inverse sine of root 3 over 2, if you're saying, well, what should I know about that? That was kind of yesterday's homework. It's an inverse statement. And since it's an inverse, it's an angle. Now, you could type it in a calculator and you could get that angle. But I'm trying to kind of cut to the chase here and suggest that, yes, that's an angle, but that also means, check this out, that also means that there's a triangle. Okay, ultimately, yeah, I like that. There's a triangle that goes with this statement. And what I'm referring to here is a triangle that has a certain y and a certain r value. Now, the reason it's y and r is because this is a sine. Let's make this triangle. Okay, because all I'm really suggesting here is that there's a y value in some triangle that's root 3, and there's an r value in some triangle that's 2. And, well, now that you mention it, it looks like that we would know what the x value is. It turns out that it's 1 based on the 1, 2, root 3. Now, I'd said a moment ago that there's an angle here. And the truth is, you would be able to determine that the angle is 60. But because this is a composition, we actually don't need the angle for the final answer. Okay, the reason we don't need the angle for the final answer is because we're now going to do the cosine of this triangle. And if you're like, what do you mean do the cosine? Well, by definition, cosine is x over r, and I have an x. I have an r. And so the cosine of this problem is 1 over 2, the x over the r. And that is actually our final answer. Now let this sink in a little bit, okay? Because for one, the final answer is not an angle. Because I want you to realize that we started with an angle, but that quickly became a triangle, which we found the dimensions. Your answer is actually the dimensions of a triangle. A little different than yesterday because, well, it's a composition. Let's kind of do the same thing before we make too many conclusions. What if I ask you to do the tangent of the inverse cosine of 5 over 13? The tangent of the inverse cosine of 5 over 13. Now, sort of same thing. Yeah, you probably with enough pushes, button pushing on your calculator, you could type that in. And if you're the kind of student you want to tinker around, you could type that in and see what happens. What I want you to understand is the theory behind this. And again, that green part in theory is referring to an angle. But of course, that angle is really a triangle. So kind of like your homework, this really means that we have, because it's cosine, we really have an x and an r. Again, because it's cosine, it's an x and an r. So we make a triangle that has an x value of 5 and an r value of 13. Now I mix things up a little bit here because you probably don't know the angle. Okay, and the truth is we don't need this angle to be able to finish this problem. What we actually need is the dimensions of the triangle. Okay, so it's this y value over here that we really should be seeking. Okay, and we go back to, of course, an old friend, the Pythagorean theorem. The Pythagorean theorem. My brother actually used Pythagorean theorem, I found out over the weekend, to figure out the distance it was from his window to the groundhog that he was picking off. A little Pythagorean theorem. I sort of had the chuckle, but he was at a window. It was on the second floor, and he wanted to figure out the distance to the groundhog. This is not normal stuff in the Naylor family, but it did make for a good laugh. But you never know when you might need Pythagorean theorem. So work that out. Okay, work that out. Yes, it comes out to be 12. Comes out to be 12. Now, when you do a composition of trig functions, your final answer is going to be the dimensions. In this case, tangent being y over x, the dimensions of our triangle. And we end up with 12 over 5. Now I'm sort of writing the answer backwards because I want you guys to see that we always started on the inside, but we worked to the outside. And that's how you always do a composition. You start on the inside, you work to the outside. And again, our final answer is actually the dimensions of the outside.
Can you do a composition with like any of the other trig functions?
Yeah. Yep, you can do it with, I'm actually going to give you one that's a little fancier. It'll be kind of one of the reciprocals. So, yeah, what else are you guys thinking? Kind of on purpose, I wanted you to have 2 problems. Anything that you're thinking here? Let me kind of help to summarize. Maybe you just want to read this. Maybe you want to copy it down. I want to provide it to you because whenever you do a composition, you always start with the inverse part. And if the color coding helps you, that's supposed to be the one that was in green. Okay, so you start with the inverse part, the part on the inside. And then your final answer, as you've seen a couple times, becomes the dimensions from that outside function, from that front function. Now, what I'm trying to get at here is a no calculator way to do these. So I know I've said, hey, you probably could type these in your calculator, but you're going to find the last couple problems we do, you really can't type them in your calculator. So you want to be able to do this triangle, sort of this triangle method. Is there anything else that you're kind of wondering? Good. I was wondering if anybody was wondering that. Okay. 2 answers to that. The one answer is you've got to come back Wednesday. On Wednesday, we'll give a better reason why that they're always going to be in the first quadrant. That's your second reason. They're always going to be in the first quadrant. Okay. Now on Wednesday, we'll talk about why it's always in the first quadrant. To give you kind of a quick teaser, it's because that's the quadrant where you have some overlapping. Okay, and I'll talk about what I mean by overlapping on Wednesday. So, but it's good news. It's actually a little easier. You only have to draw the triangle in one quadrant, in the first quadrant. Okay, and again, don't forget to come back. Now, maybe you think you got the idea, which I hope you do. I'm not trying to trick you here, but I am giving you a problem that will sort of test, are you understanding this concept? It's the cosecant of the arc tangent. And I hope you're not thrown off by the arc tangent, but I did want to write it that way because that still means inverse. So you don't have to do something funny because it says arc tangent. You should be starting with the inside. Now your final answer will have a square root in it. So if you have come to that spot, good. But it's not the square root of 3. Be careful. Your final answer will have a square root in it, but it's not the square root of 3. See if you can learn from that if you happen to be thinking that way. I see you guys quickly coming to this conclusion, which is great. It's correct. Okay, it's definitely 2 and 1, but this is not a 1, 2 root 3, right? That should even at least make you kind of cringe a little bit. It definitely would make a geometry teacher cringe. Okay, Pythagorean theorem will quickly get you to the square root of 5. Square root of 5. And then cosecant, just trying to keep you remembering these definitions. Cosecant is r over y. R over y. Okay, so we end up with root 5 over 2. Root 5 over 2. Sometimes somebody will, again, because you're kind of digging a little deeper, kind of wonder, why all the notation, Miss Naylor? I mean, why do you have to write arctangent? You're just making it seem fancy. Why can't you just write tangent? Okay. Well, actually, you can't just write tangent because this gets a little bit in the theory of trigonometry, but that would be like trying to say that 2 is an angle. That'd be like the tangent of 2 degrees. So the notation matters, although it doesn't really change the way you think about the problem because you're still going to think about a triangle. But if it wasn't an inverse right there, it wouldn't make sense, again, because it would be like 2 degrees. And then we have a whole different type of problem. 2 more problems that I'll kind of put in sort of a closing category here. Well, I don't want to say this every day, but it is kind of true because time seems to be the essence lately. We're going to have to kind of talk about these more together, but still be thinking, okay? Be thinking. There's something a little bit different about these, and I don't want to just say it all. So first of all, what about the cotangent of the inverse cosine of 0? The cotangent of the inverse cosine of 0. I don't want you to just be waiting, but I know that some of you are, but keep thinking, okay? Because what I'm showing you here is not necessarily anything that's that earth-shattering, okay? Cosine is x over r. Cosine is x over r, so 0 over 1. We want you to get to that place sooner than later. How's the triangle going? How's your triangle sketch going? What kind of triangle has an x value of 0? What kind of triangle has an x value of 0? Ah, it does make sense. That a girl? So yeah, kind of the answer is there's no triangle, but there's a point. And hearing you talk about the unit circle allows us to take that a step further. There's a point that has an x value of 0. You take a moment, you kind of think about what else you know about this point. And Hannah's thought about the unit circle is a great hint. Okay, now the place I want you to be is understanding that this point has everything that we need. It has an x value of 0, it's got an r value of 1, and by golly, it has a y value that we can now determine. And here's the thing, it's not always about a triangle. It's about a sketch, in this case, more like a point that represents those numbers. And look, you can do the cotangent, you can do x over y, you can do 0 over 1. And so just because there's a 0 in the problem doesn't mean that it's undefined or something like that. Good. So it turns out to actually be a little unit circle. I'm surprised we didn't have a outburst of emotion when we heard unit circle. We'll have to feel the love a little more here. All right, one more. Kind of in the theme of what about. In other words, maybe we have to make a little adaptation to our main strategy. We have a little more time than I thought. I don't know why I thought this class ended at 10:15. So we're good. Again, if you're waiting for me, try to be a little more in the thinking zone. This is a cosine. Yes, it says inverse. That's just because it has to. Think you know what these two numbers represent? That's supposed to be a little bit of a hint. You can take the numerator, you can take the denominator, and you can connect them to, cosine, to x and r. Now what's happening here is that one of the dimensions is a variable. Okay, the x dimension is going to be called x. Let's draw this one triangle in one quadrant, which we'll talk about on Wednesday, kind of why. Here's kind of the thinking spot. I hope you know where this problem is headed. It's headed towards tangent, which is y over x. So do you think you can find y? Okay, can you find this side? Is it going to be in terms of x? Yes. It's going to be an expression. Just at least think about it. It's going to be an expression. Now, did you put the letter y there? Because, you need something. So you can call it y. So you can set up x squared plus y squared equals 3 squared. So it's kind of like you're solving this for y. You get y squared equals 9 minus x squared. You get y squared equals 9 minus x squared, and then you take the square root. Now be careful, don't be silly. The square root of 9 minus x squared is not 3 minus x. It's not? No, it's not. It's the square root of 9 minus x squared. Okay, that falls into that category of a math teacher's nightmare, where again, I wake up at night screaming, no, it's not 3 minus x. Okay, but seriously, people are like, why not? It does fall into this category. Just like a plus b, the quantity squared is not a squared plus b squared. You cannot distribute an exponent you cannot distribute a square root because a square root is actually the same as an exponent. And it's because of this plus and minus sign that you can't square root it. Okay, so, oh, look, you get the square root of 9 minus x squared. And all you got to do is plug that in. Not really plug it in, but use those numbers for tangent. So sometimes people just need to see the type of answer that this is. It's an expression. It's just kind of making you think a little bit about variables. All right, so I end up with the square root of 9 minus x squared all over x. Composition, mathy. I appreciate your attention again with these concepts. We have one more mathy concept. It'll be Wednesday, but it does connect back to graphing, although you have to keep connecting it back to graphing. Today we actually didn't have to graph anything.
Will there always be just two operations, or is there like bigger compositions?
Well, we will only do a composition of two functions. Now, there'll be a homework helper on Google Classroom. I got to get it up there. It'll be up there by AP. Oh, shoot. Yeah.